Hi guys, we are going to talk about conical pendulum. Alright, now think this to be bob and this a pendulum. This is moving in simple harmonic motion, regarding which I have made few videos earlier. Alright, so this is SHM, simple harmonic motion. But if it is rotating like this, we call it as conical pendulum. Now this is the bob. Alright, this we call it as bob. The bob, this is the length, and when it is moving around like this, so it is creating a circle here. Alright, this is the circle which is being created, and this is the radius. So once again, length, bob, conical pendulum. Alright, okay, so let's get into this now. So it's moving in a circular motion, alright, generating a cone. Before getting into this, let me make you understand what do you mean by right circular cone. Right circular cone is a cone. Now here also we are generating a cone, right? So cone, what do we understand when we say right circular cone? Now right circular cone is this cone which is being generated just now. I moved the pendulum. Pendulum also generated a cone. Alright, generated a cone. Now when the axis is perpendicular to base, then we call it as right circular cone. When the axis is at right angle to the base, we call it as right circular cone. Alright, okay. Now the few formulae which you have got to keep in your mind, because I have found numericals coming into MCQs and varieties of other places applying these formulae. Okay, so I just felt my job to just make you aware about these formulae. Okay, so when we are talking about curved surface area, it is pi RL. What is R? R is the radius. This is the radius. Now if I check it out over here, now this is also a cone. This is the radius. So this is the radius here, over here. This is the length. So pi RL is that of curved surface, right? Curved surface. We are not taking the base. Alright. Now if you want total surface, like the curved surface at the same time the base included. The curved surface and the base included, the circular base included. That would be total surface area. That would be pi r plus L. Why? Open up the bracket, pi r square. Pi r square is that of the circle, lower part, and pi plus pi rl. Pi rl is the side part. Alright, this part, curved surface area part. So that becomes the total surface area. And volume of right circular cone, volume 1 by 3 pi r square h. So these are the things which we are also going to use in maths. So please keep it fit in your memory bank. Alright, okay. Now jumping back to our conical pendulum. Alright, rotational dynamics. Now this is the pendulum. It's making an angle theta over here. Now this is the point where we are concerned, bob. Alright, now at that bob, at this point, if we talk about this is the tension always directs towards the point where it is suspended. Alright, so this is tension T0. Alright, and bob, so mg is always vertically downwards. Now who is it which is balancing mg? It is T cos theta. So in order to understand T cos theta, let's resolve T0 first. Now before resolving T0 first, let's find out why is this angle also theta. It's anybody's guess anyways. Here it's very simple. One line, alright, another line, transversal, alternate angle. So this is theta. This is theta, this also is theta. Fine, got it. Okay, then in order to get the vector which is balancing mg, we resolve T0 into T0 cos theta and T0 sin theta. Now you should be very well aware that vector closer to theta is cos theta and away from theta is sin theta. Fine. So T0 cos theta is balancing mg. So that's what I jotted down over here. T0 cos theta is equal to mg. So what is T0 sin theta doing? T0 sin theta is balancing this centrifugal force. So that's what I jotted down over here. T0 sin theta is equal to mr omega square or mv square over r, depending upon your numerical. You can change over to your requirement. Fine. Okay. So now it's very simple. So we got omega square is equal to g sin theta over r cos theta. Can you tell me how? So simple. So you just cancel this. We want omega square. Take g there, g sin theta. Take r around there. Take r down there, r cos theta. So you get in this formula. Once you get into this, then everything is very simple. You intend to root it. We are not interested in omega square, so let it be omega. So if it is omega, the formula is the same, g sin theta over r cos theta, root of it. Now we also know that omega, let me write omega here, omega is equal to 2 pi t, where t is time period. Now I hope you know what is time period. Now if it is goes down and comes back here, the time taken for the bob to start from here and then again come back to that position, same position, is called as time period. Alright, so that is designated by capital T. Okay, now if you want it in terms of capital T, 1 over T, now we know 1 over T is also known as frequency, so you can designate it by N or by F, your choice. Alright, and 2 pi goes down, so it becomes 1 over 2 pi root of g sin theta upon r cos theta. Now you can keep on changing this, alright, as per your requirement. Suppose we intend to get rid of r, that we can. Why? Because now see, it makes a triangle, right angle triangle. This is the hypotenuse, alright, and the hypotenuse is the length also, alright. So if I go in for, and this is theta, so if I go in for sin theta would be what? Opposite. We know this is the radius of circle and it is opposite over hypotenuse, that is capital L. So r becomes L sin theta. Fine. So I can just substitute it over here. So frequency becomes 1 over 2 pi g sin theta as it is, and instead of r we write it as L sin theta, and cos theta remains, root also remains, so this gets cancelled. So now our thing gets converted to 1 over 2 pi root of g remains in numerator, alright, and what we have is L cos theta. Alright, so this is frequency. Now if you want it in time periods, inversion would occur. Now suppose if you want in terms of time period, what we would do is 2 pi would come up, alright, and your L cos theta also would accompany it. Alright, L cos theta also would accompany, let me write it properly. So L cos theta also would accompany it, and G would go down, and we have root over here. So these all becomes the formula for time period, for frequency, for omega, angular velocity, and this is what is conical pendulum. And I again remind you, please keep these things in mind also, because they may be asked anywhere in maths or in physics, numericals. Alright.